Hello my class 10 students. This is the sample paper 2 of ICSE Physics Class 10 Semester 2 exam. It is the prelim paper of one of the reputed ICSE schools. I have already uploaded the solutions of section A and the link of it is in the description. So now I shall be solving section B. I suggest that you pause the video, solve the question yourself, and then check your solution with mine. I've been teaching ICSE syllabus for physics, chemistry, and maths for 41 plus years. So if you find this video helpful, do consider subscribing and sharing the video with your friends. So shall we begin? Our section B is of 30 marks and there will be 3 questions of 10 marks each that you have to solve. Let us look at our question number 2. The first part. This is of 3 marks. As you can see, the diagram has been given and question A says, name the type of vibration observed in the diagram. In this diagram, you will see that the amplitude is decreasing with time and so it is the diagram for the damped vibrations. Why is the amplitude decreasing? The amplitude decreases because as the particles are vibrating about their mean position, some work is done in overcoming the resistive force of the surrounding. So let us see how we write the answer. So just to save on time, I have written the answers. So we write section B, next line we'll write question 2, part 1, and then answer A, damped vibrations. That will give us a 1 mark. Amplitude decreases as the particles lose the energy in doing the work against the force of friction offered by the surrounding medium to the motion of the particles. Give one example. You can write a vibrating tuning fork in air. Remember, it's important that you mention it is air or vacuum. Okay, so this is 1 mark here and this is 1 mark here, and that's your 3 mark for question 2. First part. Your second part of question 2 is definition of radioactivity. This you can find from any of the textbook. This is a learning question. Now the definitions you should learn on your own. That should give you your 1 mark. Let us look at your B subpart. A radioactive seed is placed in an electric field as shown in the experimental setup. Copy and complete the given diagram and also label X in the diagram. So we have to draw this diagram. This is the radioactive seed. This is the narrow opening. You know this is going to be the lead box and there is positive plate here and negative plate here, which means we have electrostatic field, and because of electrostatic field, this is going to give us the separation of alpha, beta and gamma radiations. So this will be the photographic plate. Let us see how we draw the diagram. So I have left a space for a radioactivity definition, and this is the cylinder having the radioactive seed. I have copied the diagram, and this is the photographic plate, which is X. And now you know that the positive terminal is here on the left and negative terminal is on the right. So the positively charged alpha particles will be deviated towards the negative and they will be deflected through the lesser angle, and then beta, which is going to be attracted towards the positive terminal because beta have negative charge. They will be deflected with more angle here because beta are lighter particles. So you will have 3 exposures here. So we will call this as A, B and C and write here separately that A will be alpha radiations, B will be gamma radiations because they will be undeviated, and C will be beta radiations. And what is X? X is the photographic plate. So that should give us our full marks. So this question will be 1 mark here for radioactivity and 2 marks for this diagram. Now we come to question 2, third part. We have a circuit diagram here. And you will see there is a cell with its internal resistance. It is shown with a box here with a dashed line, 12 volt and 1 ohm. So this becomes the EMF, this becomes the internal resistance here. We have 4 subparts here for this question. and it will be for 4 marks. So you will have 1 mark per question. Calculate the total resistance in the circuit. Now for the total resistance, we will have to see this 20 and 5, they are in parallel, and 7 and this, they are in series. And then we have this internal resistance also gets added to all that. Okay, so that will be our total resistance. Calculate the current flowing through 7 ohm. Now remember that the current is going this way, and the current in the circuit will be the current which will pass through the 7 ohm resistor. So once you find the current in the circuit, that will be our answer for the second subpart. Calculate the PD across 5 ohm. Now 5 ohm, can you see over here? The current is branching off into 2 parts, and then you will have these 2 resistors in parallel, but the end points for both the resistors are these 2. So the PD across 5 ohm will be the PD across these 2 points. Okay, so if we call this as V or V1, then we will have to find out the PD across parallel circuit. This PD will be the same for 5 ohm as well as 20 ohm. Calculate the current in a 20 ohm branch. The current will be, now if you call this as I1 and this will be as I2, then this will be your R2, 20 ohm will be your R2, and then we will have the current, lesser current in 20 ohm and more current in 5 ohm. It will be inversely proportional to the resistance. Okay, so let us see how we write these solutions. So we have drawn the diagram here, and the total R in the circuit, this 20 ohm and this 5 ohm, they are in 2 separate branches here, so they are connected in parallel. We write that, and 1 upon Rp, that is resistance in the parallel circuit, will be 1 upon 20 plus 1 upon 5. That will give us 20 as the LCM, and 1 plus 4, that will give us 5 upon 20. 5 ones and 5 fours, so you'll have 1 upon 4 as 1 upon Rp, and Rp will be 4 ohm, and total resistance in the circuit will be 7 ohm, that is this one, plus Rp and plus this 1 ohm. Can you see that? So 7 plus Rp plus R, so 7 plus 4 plus 1, that is 12 ohm, and that is our answer A, and that is going to give us 1 mark. The second subpart says current through 7 ohm. Now current in the circuit, that is I is equal to E upon R plus R. What is EMF? EMF is given in the diagram here. Can you see that? 12 volt, that is the EMF. And so we will have 12 upon R plus R, that is internal resistance 1 plus this, which is 11. So that will still make it 12. Even if you don't write this way, you directly write here 12, that's also fine. So that will give us 1 ampere. That's your answer B. That is your 1 mark. The C part says PD across 5 ohm resistor. That will be PD across the parallel circuit, and I'll call that as VP. And remember, V is equal to IR according to Ohm's law, right? So VP, that is PD across parallel circuit, will be I into RP, that is resistance of the parallel circuit. So we have 1 ampere, which is the current in the circuit, and RP was 4 ohms. Remember that in the first answer, and that will give us 4 volt, and that is our answer C, and that is your 1 more mark. And then we come to the D part, where it is asked current in 20 ohm branch. So that will be I1 equal to Vp upon R1, because we know that V is equal to IR, and therefore you will have I equal to V upon R. So we can write here I1 and R1. It doesn't matter whether you write I2 here or R2 here. That's perfectly fine. So 4 volt upon 20 ohm, and that is 4 ones and 4 fives, that is giving us 1 upon 5, that is 0.2 ampere, and that is our answer D, and that gives us our 1 more mark. So we got 4 full marks. Let's come to question number 3. We are coming to question number 3. Now remember, each question is for 10 marks and you have an option of choosing 3 questions from section B. So you can choose any 3 questions of your choice from section B, but I will be solving each and every one of these. Okay. Now the first one says define latent heat of fusion. All the learning work you'll have to do on your own. It's important that these important definitions you know by heart. B part. What is the effect of increase in pressure on the boiling point of water? Give one application and then see what happens to the heat supply during the change of state. Now let us see how we write these answers. So I have left a space for 3A, latent heat of fusion. As I said, you have to know these definitions by heart. B part, increase in pressure increases the boiling point of water. The example of the pressure cooker, remember pressure cooker, there is increase in pressure on the surface of water, and so water boils not at 100 degrees C but around 120 to 125 degrees C, and so it has increased the boiling point. So remember, it's directly proportional. Increase in pressure increases the boiling point, and you can underline the keywords like this, and the application right in the next line, pressure cooker, and underline it. So that will give us 1 mark here, and this will be again 1 mark here, and then we come to C part. Heat supplied during the change of state. What does it do? It increases the potential energy between the molecules. This much will be enough for that 1 mark. We don't have to write about kinetic energy being constant and the distance of separation increasing, because the question is just asking heat supplied, how does it change the energy? So it is going to change the potential energy. We come to question 3, second part. A. Name the part of the appliance that should be earth. Why should a fuse be connected in the circuit with the given earthing? That is for 2 marks. So name the part will be for 1 mark. And why should the fuse always be connected in the circuit for this earthing? That will be the 2nd mark for this. And the B part, draw a label diagram of a 3-pin plug, and that is for 1 mark. So for A, we write the metal casing of the appliance should be earth, and that would be our 1 mark. Then we talk about the fuse. Where it should be connected? It should be connected with the earthing, so that due to short circuiting or faulty appliance, large current is conducted to the earth through the earth wire, and as a result, the fuse in the circuit will melt and it will break the circuit. Remember, the fuse melts and breaks the circuit because of the large current that is conducted if there is short circuit or faulty appliance. And so it keeps the appliance and the user safe. So this is again for 1 mark. And then we come to the 3-pin plug. Now 3-pin plug, the way I have drawn, it's not looking very artistic. But remember, you are not being checked for your artwork. You have to just show the 3-pin plug, write 3-pin plug and show the 3 pins. Now 3 pins, you'll have to make sure that this earth pin, it is longer and thicker than the others. And each one should have the splitted ends here. The split end should be here. And the top pin, which will be of larger diameter, is the earth one. And the live is on the left and neutral is on the right. Once you have shown this much, that should be enough to give you your 1 mark. Question 3, third part. Do not copy the diagram, and they have given us a solenoid here with the center 0 galvanometer attached. And then we have the north pole of this magnet is brought closer. State your observation when the north pole of the permanent magnet approaches X and write the reason. Now when the north pole comes closer, by Lenz's law, this will become north polarity here at X, which means the current will have to be anti-clockwise. So you got to see from this side whether the current is going to be clockwise or anti-clockwise. Now, if it is coming from under and over, then it will become clockwise. So, what if it goes from over it goes under, which means in this loop it is going this way. It is going anti-clockwise when you look from here. Okay, so you will see that the current is going this way, going over and under, coming this way, and the galvanometer needle center zero will be like so. The current flowing this way, so we will have the galvanometer needle turning to the left. Let's see how we write it. The galvanometer shows deflection to the left. And we have to write the reason also. And this is so as north polarity is induced at end X of the coil when the north pole of the permanent magnet is brought closer to it by Lenz's law. So both of these together is going to give us 1 mark. So if one of them is wrong, you will not get any marks. You will not get half mark also. Okay? Because both of these are for 1 mark. So because of the north polarity, anti-clockwise current will flow at end X, making the current flow in the galvanometer from right to left, as I showed you in the diagram. State the polarity induced at X. It is north polarity induced here. Name the law that is required to identify the polarity, and we write it like so. North polarity induced at X and Lenz's law. And this together again will give us 1 mark. C part. State one way in which the magnitude of the induced EMF can be increased in the coil. Now out here, the induced current depends upon the number of turns also, but because I know that this structure is going to be constant, I'm not going to make any changes here. And this magnet also, if I use a stronger magnet, it will induce more current. But I have been given the magnet, so I can't change that. So under the circumstances, if I have to increase the EMF, I will have to make sure that the rate of change of magnetic flux should be more, which means I have to move this magnet quickly. So I have to increase the speed with which the magnet is moving towards the solenoid, and that is how we increase the EMF. So how we write? Magnitude of the induced EMF can be increased by moving the magnet faster. So the rate of change of magnetic flux will be more. And the D part is the energy conversion. We are moving the magnet and we are inducing the EMF. So we'll have mechanical energy to electrical energy, and that will give us our 1 mark here and 1 mark here. Okay, can you see D part? State the energy changes during this. Now let us come to question number 4. We have to choose our questions very well, okay, so that we don't lose marks. Question number 4. The diagram shows a current carrying coil. The arrow shows the direction of the current. A. Complete the external circuit and draw at least 3 magnetic field lines around the current carrying conductor. Show in the diagram the direction of the magnetic field produced and label the diagram. And that is for 2 marks here. The B part says state 2 characteristics of the magnetic field lines induced, and that is for 1 mark. So we have drawn the loop, and the external circuit to be completed is to be done like this. The external circuit must have the cell, the key and the rheostat. And the cell must have positive end from where you will see the current leaving. So you see the direction of the current is like so, which means I will have the current flowing in the circuit from here. So this becomes positive end and this becomes the negative end. Alright. So we finished the first part. Now we have to show the 3 magnetic field lines. So 3 magnetic field lines we will show at this point, and then at the center here. Now remember here the current is coming upwards like this. So we have to use right hand thumb rule, and that will give us anti-clockwise current, and we write here anti-clockwise magnetic field at this point. Then at this point you will see the current is going down. So it will be again right hand thumb rule. You put the thumb pointing downwards and the enclosed fingers will give us the clockwise direction of the magnetic field. So we say clockwise magnetic field. and at the center you will see this magnetic field is going this way. So if we have one more, it would have gone this way, one more, it would have gone this way. So at the center it is going to be this way, the magnetic field into the plane of the paper. So I have shown this arrow, can you see that? And I've written magnetic field into the plane of the paper. Then in the B part, we had to write the two characteristics of magnetic field line. Number one, now this is all learning work, okay? Number one, magnetic field lines around the conductor, they are concentric with the wire as the center. And the second one, magnetic field lines are denser towards the conductor and they become rarer as we go away from it. Let's come to the second question. A vibrating tuning fork is placed over the mouth of a burette filled with water, and the tap of the burette is open. The water level gradually starts falling. It is found that the sound becomes very loud at a particular length of the water column. Name the phenomenon and give reason for this phenomenon. Second part A, first part has the answer as resonance because the loud sound is heard. And then second part asks us, why did it happen? So we say this is so as at a particular length of air column, the frequency of the air column will be equal to the frequency of vibration of the tuning fork, which is the external periodic force. And then the air column readily takes up the vibrations and produces loud sound due to resonance. Okay, so let's come to B part. Distance of the receiver of sound increases 4 times from the source. By what factor will the loudness of the sound change? Now this is like a comparison question. So the distance has become 4 times. So I'll make a column like this, case 1 and case 2. D1 is D and D2 becomes 4D. Why? Because distance has increased 4 times. Now loudness is proportional to 1 upon distance square. So loudness proportional to 1 upon D square. So L1 upon L2 will be D2 square upon D1 square. Now we substitute. D2 is 4D, can you see that? So we write 4D whole square, and D1 is how much? This. So that is your D square. It is 16D square upon D square. So D square gets cancelled and you get 16. Which means your L2 is going to be L1 upon 16. How did we get that? L1 upon L2 is equal to 16. So L2 comes here and 16 goes there. Okay, so that's how we get L2 equal to L1 upon 16. So whatever loudness we had initially, the new loudness is 1/16th of that. So loudness become 1/16th of the original. And that is our answer. Okay, so that's how we get our full marks. Remember that. We come to the third one. The electric heater is rated 220 volt, 1200 watt. It raises the temperature of 2 kg of substance from 32 degrees C to 50 degrees C in 3 minutes. Calculate the heat capacity of the substance, specific heat capacity of the substance, and name the material of the calorimeter. What is it made up of and why? There are 3 parts over here. So this will be for 1 mark, this will be for 1 mark. Name the material and why. That would be for 2 marks. Okay, 1 mark for this and 1 mark for the other. So to get the clarity of thought, I again make the 2 columns. We have the heater. I have written all the details of the heater. We have the PD, the power and the time. Now time is given in minutes, so I will write it in seconds. Then the substance, the mass is 2 kg and we have to find the heat capacity, means C dash. What is C dash equal to? C dash is equal to mass into specific capacity. And the second part they ask you what is the value of specific capacity, which is small c. So by the principle of calorimetry, heat supplied by the heater will be equal to heat gained by the substance. Heat supplied by the heater is going to be electrical, which got converted into heat. So we'll have P into T will be equal to heat gained by the substance is mc delta T. You know the formula as well. Now we want heat capacity, so we put a box here for M into C because C dash is equal to M into C. And for this we'll write C dash. Everything else we know. Power we know, time we know in seconds, delta T we know. Can you see that delta T we found out? Okay. Then heat capacity would be equal to this divided by 18. Can you see that? Simple calculations. And then you'll have joules per degree C. So we'll have 12,000 joule per degree C. Now when we want to find SHC, we are going to use the formula C dash is equal to M into C. So your C will be equal to M goes that side. It becomes C dash upon M, correct? And I've written the reason here. Now substitute the values. What are the values? C dash, we already got this value. Can you see that? Divided by mass, it was given as 2 kg. Now 2 ones and 2 goes here, 6,000 times. Okay, so it will be 6,000 joule per kg and per degree C, and that is how we get our answer. So this is your 1 mark for this. This is for 1 mark, and then we come to what is calorimeter made of. So it is made of thin sheet of copper, and that is our 1 mark. And why? Because it's got less specific capacity and it takes negligible amount of heat from the contents to acquire the temperature of the contents. Okay, this phrase is important. You have to know this by heart, and that is going to give us 1 mark. You must also mention that it's a good conductor of heat. Alright, so let's move to the next question. Now we are coming to question number 5. Now remember, so far we have finished with question 2, 3 and 4. In section B, you will have to attempt only 30 marks worth. So we have already finished 30 marks worth, but we are doing the last question of the paper because we are solving all the questions. For you, you have to choose any 3 questions. Let's come to the first part. Give reason. An alpha particle has highest ionization power. The electrical appliance in household wiring is always connected in parallel, and people working around a nuclear reactor wear special film badges. Let's see how we write the answers. Now, alpha particle is a doubly charged helium nucleus which has large mass compared to beta particle, and it also has less velocity. So, it will ionize the gas through which it passes effectively, and it will have the highest ionizing power. Okay, so these are the facts that you should mention for this. Look at RB. The electrical appliances are connected in parallel. Why? Because number 1, each appliance can work at its power at the same potential difference. You know that the potential difference we have in India is 220 volts, right? And then the second point will be each appliance can work independently. If one appliance doesn't function or it's switched off, the other appliances continue to function. They keep working effectively. So these are the 2 major important things for this answer. So this again is your 1 mark. Writing both the points, we come to why special film badges are worn by the people working around the nuclear reactor. They get exposed to the nuclear radiations, and the exposures can be checked from time to time by the film badges, and the people with more exposure than the safe limit can be moved to another department for their safety. So remember, this also is a learning type of question. This is your 1 mark. Let's look at the next question. The temperature of a 300 gram cold water rises by 10 degrees C when 150 gram of water at 50 degrees C is mixed. Determine the initial temperature of the cold water and name and state the principle used. So this will be for 2 marks and this will be 1 mark. So let's write it. Now we make the columns like this: substance, mass, SHC, T1, T2, delta T. You may have a different method, but I prefer this because it gives me clarity of thought. Now remember, SHC of cold water, hot water is going to remain the same. So I'm just going to write over here C. Now final temperature is going to be the same for both the quantities of water, But remember, the cold water has initial temperature X, which we have to find out. And it has increased by 10 degrees C, and so my final temperature is X plus 10 degrees C. Got that? The cold water will have its temperature increasing. Now X plus 10, whatever this number is, this also will be X plus 10 degrees C. Agreed? But we know over here delta T is 10. But what will be the delta T over here? Now some of you would get confused, so I'll just show a thermometer here. And I'll have cold water and hot water. The temperatures, cold will be X and hot will be 50 degrees C. And somewhere in the middle will be your X plus 10. Agreed? Now, if I take the difference between these two, that is going to be this minus X, that is 10, we already know. But for these two, the difference between the temperatures will be higher temperature minus lower. So it becomes 50 minus X plus 10. That gives us 50 minus X minus 10, which means it gives us T minus X, right? Now we will say, by principle of calorimetry, we will have heat gained by which water? Cold water is equal to, tell me, heat lost by which water will be losing heat? The hot water, correct? So we will call this as M1C delta T1, and here we will say M2C delta T2. And this C is the same for both, because both of them are different quantity but of water. So M1 will be 300 gram multiplied by delta T for cold water is 10, and for M2 the mass is 150, you can see that here, and delta T is 40 minus X. Now here easier calculation would be like this, because this is single term here and this is single term here, this multiplied by this. Now 15 ones and 15 twos 30, I'll write here 20. So I'll have 20 equal to 40 minus X. So we'll have X equal to 40 minus 20, and that will be equal to 20 degrees C. What is 20 degrees C? That is the initial temperature of the cold water. So that should give us our 2 marks. Let us come to the next one, the principle of calorimetry, which states that heat lost by the hot body equals heat gained by the cold body. Okay, let's move to the next question. Complete the following equations. Rewrite the equations by adding the correct values. So we have A, this reaction here, and this reaction here, and this reaction here. What is a D? Write the equation showing the change that occurs in the nucleus of an atom during beta emission. So let's copy this and then let's start writing. Okay, so if it's alpha emission, it is going to give away alpha. So here it becomes helium, and helium is written 4, 2. Mass number is 4 and atomic number is 2. This is helium nucleus, alpha particle. So the mass number of this X will be 238 minus this 4 means 234, correct? And this is 92 and 2 particles are out, which means this will be 90. So this is first equation that will give us out 1 mark. Now Z 108.88 is emitting beta particle. So beta particle means here there will be electron, which will be 0, minus 1. So this 88 is going to be this minus 1, which means is going to be 89. Remember, in beta emission, the atomic number increases by 1. Will the mass number change? No. So it will be 108 as it is. But it is emitting gamma particle. That's why it's written here asterisk. So it will be X. It will not become another element. It will be X with the same atomic mass 108 and same atomic number 89. Now here the C part, Y, A, B, alpha and beta particles are given. Now if we are having alpha given out, so I'll have helium 4, 2, and I will have here electron 0 minus 1. By the way, this is not possible because we are not having any time alpha and beta given out simultaneously. You must remember that. But since it's asked in the question, we'll have to be obedient to the question and not argue with it. Okay, it is not possible. Hence, the question is wrong. You can't say like that. Okay? So, now if it is A, then from A 4 particles are gone and 0 particle. Can you see? Mass number is A here and 4 here and 0 here. So here for Z it will be A minus 4. Okay? If we show it in the working column, it will be B minus 2, that is minus 2 because of alpha particle having been given out, and beta means it will be atomic number increasing by 1, so that will give us B minus 1, and so we can write here B minus 1. Alright, now during beta emission, what is the change that takes place in the nucleus? We know that one neutron splits into a proton and an electron. So proton is P11 and electron is 0 minus 1. And so your XAZ with minus beta, that means because of beta emission, this A mass number remains A, mass number remains the same. And Z becomes Z plus 1 because one proton is created. Okay, proton with positive charge is created. Here there was no charge for neutron, but now it has become positive charge. And this electron is going to be thrown off from the nucleus as beta particle. So I've written that also. Neutron splits into a proton and an electron. This electron is emitted from the nucleus as beta particle, and this is your beta particle here. Okay, so that gives us a 1 mark. So I hope you have understood how to solve the questions, how to write the keywords, how to present your work. Hope you found this video helpful. Consider subscribing and sharing this video with your friends. Work well for your exams. All the best. Bye.